Alright, in this video here we're going to talk about solving logarithmic equations, just doing a couple examples of solving logarithmic equations. So I just did another video where I went through the steps of how to solve a logarithmic equation with a couple fairly basic examples as well. So if you haven't seen that video yet, you might want to check that one out where I explain, this is first do this, then do this, then do that to solve a logarithmic equation. And then you'll be ready to jump in and just look at these examples that we're about to do here. Alright, so my first example, 4 plus 3 times log of 2x equals 16. Alright, so first thing, identifying the type of function. There's a log there, so it's pretty obvious that this is a logarithmic equation. There's a log there, and the variable x is inside that parentheses of the log. That's what makes it a logarithmic equation. Alright, so I identify that it's a logarithmic equation, so now I need to make sure that I use the methods that are appropriate for logarithmic equations, right? Which means, not just trying to divide this log to the other side to get rid of it or something like that. There's a process that you use to solve a logarithmic equation. So when you have this type of equation, you have to follow that process in order to get the solution, right? You can't just see a logarithmic equation and try to solve it as if it was a linear equation or a quadratic equation. That's not going to work. All right, so first step of solving a logarithmic equation is isolating the logarithmic term. Now the logarithmic term in this case is the log 2x, right? It's the logarithm with the base, if there's a base there. This one, the base isn't written, which means it's the common log, base 10. Right, so it's the log with the base, and then whatever's in those parentheses, that argument of the logarithmic function, that's the logarithmic term. Right? Isolating that means we need to get rid of this 3 and also this 4 over here. Right? We need to move those numbers to the other side using basic algebraic maneuvers in order to do that, to get the log of 2x all by itself. Alright, so if I need to get the log 2x by itself, it's almost like this whole big thing that I just underlined here is my x, and I want to solve for the x. So the first thing I would do would be subtract the 4. Alright, so let me subtract 4 on both sides. That's going to give me 3 log of 2x equals 12. Alright, so I subtracted the 4 over, and then I have 3 times the logarithm, and the opposite of multiplying by 3 is dividing by 3. Alright, so I divide both sides by 3, and I get log of 2x equals 4. Alright, so those first couple steps here of doing the algebraic work is actually step number 1 of the process of solving a logarithmic equation. I need to get that log and the parentheses by itself, right? The log of whatever it is needs to be by itself before I can proceed to the next step of the process, which is switching to exponential form. Alright, so after I get my log isolated, and when you're doing this, this is how the equation should look. It should have a log. Maybe there's a base number written there. Not always, but there could be. And then something in parentheses equals a number. Right? When you get it into that form, that's when you're ready to proceed to step 2. If you have anything else here, numbers being added or subtracted or multiplied by that log, those need to be moved aside before you're ready to proceed to step 2. Right? So log of parentheses equals a number. I'm ready for step 2. Which is switching to exponential form, right? The key step of solving a logarithmic equation, since exponentials and logarithms are inverses of each other, to solve a logarithmic equation, I need to use that exponential form to make it happen, right? So to switch from log form to exponential form, I start with the base of my logarithm, which remember, since it's not written there, we know that it's the common logarithm with base 10. Right, so it's going to be a base of 10 raised to the power on the other side, so 10 to the 4th power equals whatever's in those parentheses, which is 2x. Right, that's the switching from the log form to the exponential form, and it always goes that same way. It always follows that same pattern. Start with the base, powers on the other side of the equal sign, so 10 to the 4th power equals whatever's inside those parentheses. Every time you're solving a logarithmic equation, that's how you get rid of the logarithm. Right? I've seen students in the past make the mistake of, log 2x equals 4, let me divide both sides by log, and then 2x equals 4 over log. Mathematically, it doesn't make any sense whatsoever. You cannot have a log without an argument, like a log of something, right? Just a log by itself mathematically doesn't mean anything, right? So I can't just divide the log to try to get this x by itself. In order to eliminate that logarithm, I need to switch it to exponential form. That's how you solve logarithmic equations. Make sure you're doing that each time you try to solve a logarithmic equation. All right, so I get 10 to the 4th power equals 2x. And now, step number 3 of my process of solving a log equation, after I switch to exponential form, solve for the variable, right? Whatever type of equation I have now, which in this case is just a linear equation, right? Because I have 2 times x equals a number here, 10 to the 4th power. So I just use whatever algebra is appropriate to solve whichever equation I'm left with. Before I actually try to solve it, though, 10 to the 4th power. What is 10 to the 4th power? That would be 10,000. Right, so my equation becomes 10,000 equals 2x. Right, to do a 10 raised to a power, whatever that power is, that's how many zeros are going to come after the 1. Right, so 10 to the 4th power is 1, followed by 4 zeros. And if you forget that, it's just 10 times 10 is 100, times 10 again is 1,000, times another 10 is 10,000. So you got it right there. Right, so 10,000 equals 2x. When you switch to exponential form, you do want to evaluate that exponential thing. Right, make sure you do 10 to the 4th power and write that number. And then to solve for x, since it's 10,000 equals 2 times x, if I just divide both sides by 2, I get the x by itself, and 10,000 divided by 2 equals 5,000. So my solution to this equation is x equals 5,000. All right, that's it. That's solving a logarithmic equation. Step number 1, get the log of parentheses. Whatever's in those parentheses doesn't matter. Get that by itself. Right? Remember, whatever's in that parentheses, I can't touch. I can't divide this 2 to the other side and just have log x equals 2. The log and what's in parentheses, those things go together. You can't touch anything in the parentheses until you switch that log into exponential form. Then you're allowed to divide that 2 to the other side after that log goes away by switching to exponential form. Again, the key thing of solving these equations, and if you don't do that, if you don't switch it to exponential form, you're not going to come out to the right answer, right? So you have to just remember that when I'm solving a log equation, I'm going to have to switch it to exponential form. That's what I need to do. Just like if you're solving a quadratic equation, I have to factor it or I have to use the quadratic formula. That's what I have to do to solve a quadratic, right? To solve a logarithmic, you have to switch to exponential form, which I've said, 5, 6, 7 times in this video already. But the more you hear it, the more likely you are to remember it. So when you're solving a log equation, switch it to exponential form. There, I just said it again. All right, now, remember though, when you're switching to exponential form, you have to get that log isolated first, right? I can't go back up here to this original equation and just switch that to exponential form. That's not going to work because, if I have the base raised to this power equals this over here, well, what about the 3 and the 4, right? Those kind of completely get left out of this little pattern. It has to be the 10 to the 4 equals this, and there's nothing else over here getting in the way, right? Which is why I have to subtract that 4 and divide that 3 before I can switch to exponential form. Right? Otherwise, if I try it up here, what do I do with this other stuff, this 4 and this 3 that's kind of hanging out in front? It won't work, right? All right, and then once again, when you're solving a log equation, when you get your answer, you can check it out. So if I plug x equals 5,000 back into the original equation, I'm just going to pull out my calculator and type it in. If I do 4 plus 3 log, and remember, it's a common log with base 10, which is the log button on the calculator, log 2 times 5,000, it should come out to 16, and it does, just to show you, right? So 4 plus 3 log of 2 times 5,000 tells me it's 16, which is what that was equal to over here. So when I plug x equals 5,000 back, my equation checks out. That's how I know I got the right answer. All right, so that's our first example here. I'm going to pause the recording and then put up another example that will work through solving a logarithmic equation. All right, the next equation we're going to look at here to solve log of x plus 2 plus log of x minus 1 equals 1. All right, so step number 1, isolate the logarithm on one side of the equation. You might have to combine logarithms if you need to, right? So in this case, we have 2 logs on the same side of the equation. So before I can isolate a logarithm, well, I can't really isolate something when there's 2 of them there, right? Isolate means there's one all by itself. So in order to isolate my logarithm, I need to combine these together using the laws of logarithms. And if you didn't watch the video that I did on laws of logarithms, you should check it out because you have to use that sometimes when you're solving logarithmic equations, right? Basically, you can add and subtract logarithms as long as they have the same base, right? And this one there's no number there, so it's base 10, it's the common log. This one, also no number, so also base 10, the common logarithm, right? Just like that last example we looked at. So, since both of these are base 10, I am allowed to add them together, and the law of logarithms for adding says, to add 2 logarithms, I combine them into a single log, I keep the base the same, and I multiply the stuff that's in here. So I multiply together the x plus 2 and the x minus 1, and then still equals 1 on the other side of the equation. Right, so log of x plus 2 times x minus 1 equals 1. Now my logarithm is isolated on this one side of the equation. In order to isolate it, I had to combine those separate logs together. right? So if you ever have an equation where you have two logs being added, you combine them as long as the bases match. If the bases don't match, you can't do that. To solve that equation is going to be a lot more complicated, and I'm not going to be doing any examples like that because you rarely see that type of thing, in algebra or precalculus classes. You combine them by multiplying. If it was subtraction here, you would combine these two with division, right? Those are basically the things that can happen when you're combining logarithms using those laws of logs. All right, so I combine them together. My logarithm is isolated now. I'm ready to switch to exponential form, right? It's the common log. It's base 10. There's no number written there, so I assume that it's a 10. So it's 10 raised to the first power. All right, so 10 to the first power equals all of this stuff in here. X plus 2 times x minus 1. Right, and now that's the equation that I need to solve. All right, well, first off, 10 to the first power equals 10. So let me just write that as a 10 and without the exponent there. And then over here, you might think, well, this is already factors, so let me set each of those factors equal to 10, and then I can solve each one. Remember, you can only do that if the two factors multiplied together equal 0. Right? If it equals any other number, you can't just separate the two factors. So what I need to do to solve this is actually multiply all this together. Right? X times x is x squared. X times minus 1 will be negative x. 2 times x will be plus 2x. So that's going to work out to be a plus 1x. And then 2 times negative 1 is going to be minus 2. And I can see here I've got a quadratic equation, right? Now there's an x squared here, which means I need to get everything to the same side. So let me subtract this 10. And I'm left with 0 equals x squared plus x minus 12. And that's the equation that I now need to solve in order to solve this original equation for x. All right, so I have a quadratic equation, so I have to do the algebra that's appropriate for quadratic equations, which means either factoring or using the quadratic formula. And for this one, I'm pretty sure I'll be able to factor it. If you haven't watched the videos that I did on factoring, you should. There's a whole bunch of different factoring methods. And even when you're solving a logarithmic equation, sometimes factoring comes up. Right? It's one of those things that is a very useful tool to be able to do a lot of higher level math. You got to be able to factor things. All right, so I look for two numbers that multiply to negative 12 and add up to positive 1. So that's going to be a plus 4 and a minus 3. All right, those will multiply to negative 12 and add up to positive 1. So we get 0 equals x plus 4 times x minus 3. Once I factor, I separate my factors, so x plus 4 equals 0, and then x minus 3 equals 0. I solve each one of those, so when I subtract 4 to the other side, I get x equals negative 4. When I add 3 here, I get x equals positive 3. Right, so I get two solutions to this quadratic equation that I ended up with. But just like we saw in some of the other videos that I did, where we started with like square root equations, and there was another type too that I can't remember right now. But sometimes if you're solving one type of equation and it turns into a quadratic equation, sometimes you get what we call extraneous solutions, right? Solutions that don't actually solve the problem, the original equation, right? Both of these will solve this quadratic equation, but will both of those solve this original logarithmic equation? Oftentimes, when you're solving a logarithmic equation that turns into a quadratic, one of those answers sometimes doesn't work, so you need to check those out to look for those extraneous solutions. Right, and if this part here, I kind of did this part real quick of solving this quadratic equation. If you didn't really follow that, go back and look at some of the videos that I did on solving quadratics where I do similar types of problems and explain it in a lot more detail. Right, but at this point, with working on logarithms, when you see a quadratic equation like that, you should be able to solve it pretty quickly without too much hassle. Right. All right, so do these answers work? If I take x equals negative 4 and plug it back into my original equation, and let me actually erase some of these steps here so I have room to do that. All right, so if I do log of negative 4 plus 2 plus log of negative 4 minus 1, does that actually equal 1? And actually, it doesn't, because if you recall something about logarithmic functions, you cannot do the log of a negative number. Right? So this is going to give me log of negative 2 plus log of negative 5. Right? That does not equal 1, because log of negative 2 does not exist. Log of negative 5 also does not exist. So x equals negative 4 is what we call an extraneous solution. Right? It solves this quadratic equation, but it does not solve the original equation. Right? So anytime you're solving logarithmic equations, you have to check to make sure that your answers actually work. You can never have a log of 0, and you can never have a log of a negative value. If you plug your answer in here and you end up with a log with a negative number in parentheses, you should know right away that that answer is just not going to work. It will not work. Right? And I'll leave it up to you to check x equals 3. If you plug that into each of these, and since these are the common logs, you can put those in your calculator. You'll see that when you plug in x equals 3, it does actually add up to 1, and so x equals 3 is a valid solution. right? So that's solving some logarithmic equations. Make sure you check for those extraneous solutions.